Have you ever wondered if we're alone in the universe? Turn your eyes to the red planet Mars. Mars, the fourth planet in our solar system, is often called the red planet because its reddish appearance is visible even to the naked eye. This hue comes from iron oxide, or as we commonly know it, rust, that dusts the planet's surface. Mars and Earth have more in common than you might think. Both planets have varied geographies with mountains, valleys, and even the largest volcano in the solar system, Olympus Mons, found on Mars. But don't pack your bags just yet. Mars is about half the size of Earth, with a day only slightly longer than ours, and a year that lasts almost twice as long. Despite the harsh conditions, Mars's similarities to Earth make it a prime candidate in the search for extraterrestrial life. Our fascination with Mars isn't new. It dates back to ancient times and continues to the modern era of space exploration. Our journey to Mars started not with a step, but with a glance through a telescope. Just as Galileo first peered at the stars, our understanding of the red planet began as a mere flicker in the night sky. As telescopes improved over the years, so did our curiosity for what lied beyond our own world. Then came the space age, and with it, our first actual visit to Mars. The Mariner 4 mission in 1965 marked the first successful flyby of Mars. Despite its brief encounter, Mariner 4 managed to send back 21 photos, giving us our first close-up view of another planet. These grainy black and white photos showed a cratered, seemingly lifeless world, a stark contrast to the lush green Earth. Fast forward to 1976, and we made our first successful landing on Mars with the Viking 1. It was a monumental achievement, like taking our first breath in a new world. Viking 1 was equipped with a host of scientific instruments designed to study Mars's geology and search for signs of life. It sent back stunning photos of Mars's surface, its rocky terrain a testament to the planet's tumultuous past. But these early missions did more than just capture images. They also collected vital data about Mars's atmosphere, temperature, and weather, providing valuable clues about the planet's history and potential for life. They detected traces of water vapor in the atmosphere and evidence of ancient riverbeds and floodplains, suggesting that Mars once had a warmer and wetter climate. From these initial explorations, we learned that Mars is not just a static, barren world. It's a dynamic planet with a complex history, one that could possibly harbor life under its rusty red surface. And so our fascination with Mars continues. Each new mission brings us closer to unraveling the mysteries of the red planet, inching us closer towards the ultimate goal of human exploration. These early missions paved the way for more advanced exploration and our quest to answer the question, is there life on Mars? From the first landing of Viking 1, we've sent more sophisticated explorers to the Martian surface. Our journey started with Sojourner, the first successful Mars rover, part of the Mars Pathfinder mission. This little robotic geologist was the size of a microwave, yet it was able to capture stunning panoramas of Mars and analyze the composition of Martian rocks, providing our first taste of the Martian landscape. Next, twin rovers Spirit and Opportunity took the mantle. These golf cart-sized rovers were designed to last 90 Martian days, yet Spirit roared on for over 6 years, and Opportunity, astonishingly, for nearly 15 years. They found evidence of past water activity on Mars, suggesting that conditions might once have been suitable for life. Then came Curiosity, the car-sized rover, equipped with a full mobile laboratory. Curiosity's mission was to determine whether Mars could have once hosted life. It discovered that Gale Crater was once a lake, and that conditions were indeed suitable for ancient microbes. Perseverance, the most recent rover, is on a mission to seek signs of ancient life and collect samples of rock and regolith that might be returned to Earth by future missions. It's also testing new technologies to assist future human exploration of Mars. But it's not just rovers that have been exploring Mars. We've also sent stationary landers like Phoenix and Insight. Phoenix confirmed the presence of water ice in the Martian subsurface, and Insight is studying the deep interior of Mars, hoping to learn more about how terrestrial planets like Earth form. Each of these explorers, in their own unique ways, has expanded our understanding of Mars. They've shown us that Mars is not just a barren red desert, but a world with a complex and dynamic history. They've discovered evidence of water, the building block of life as we know it, and they've paved the way for future human exploration of the Red Planet. These robotic explorers have given us incredible insights into the Martian environment and potential for life. Water is essential for life as we know it. So, has there ever been water on Mars? This is a question that has intrigued scientists for many years. The answer? Yes, and the evidence is quite compelling. Let's start with the discovery of ice on Mars. In 2008, NASA's Phoenix Mars lander touched down near the Martian North Pole, where it discovered water ice just below the surface. This was a groundbreaking discovery because it was the first time that water, a vital ingredient for life, was confirmed to exist on the Red Planet. In addition to ice, there are signs of ancient riverbeds on Mars. Pictures sent back by various Mars rovers show landscapes crisscrossed with old river channels and deltas. These features suggest that water once flowed across the surface of Mars, potentially creating an environment suitable for life. The exploration of Mars has also revealed the existence of certain minerals that can only form in the presence of liquid water. For instance, the Mars rover Opportunity found evidence of gypsum, a mineral that forms in water, on the Martian surface. But what about present-day water? Could there still be liquid water on Mars? In 2018, scientists announced the discovery of a subglacial lake on Mars. Using radar data from the Mars Express spacecraft, they detected a 20-kilometer-wide lake of liquid water, buried under 1.5 kilometers of Martian ice. This discovery suggests that liquid water might still exist on Mars today, hidden beneath the surface. The discovery of past and present water on Mars is not just about the possibility of life on the Red Planet, it also has implications for future human missions to Mars. Water could be used for drinking, growing food, and even producing fuel. So, to answer our initial question, yes, there has been water on Mars, and there might still be water there today. The presence of water on Mars opens up exciting possibilities for the existence of past or present life. Mars may be a cold, dry desert today, but what was it like in the past? Let's dive into the enigmatic atmosphere and climate of Mars. The Martian atmosphere is thin, composed primarily of carbon dioxide, with traces of nitrogen and argon. This thin atmosphere doesn't retain heat very well, leading to chilly temperatures that can drop to a frigid -90 degrees Celsius at night. Despite the cold, Mars experiences weather patterns and seasonal changes, much like Earth. In the Martian winter, carbon dioxide freezes over the poles, creating a winter cap of dry ice. When this cap sublimates in the spring, it triggers dust storms that can envelop the entire planet. The dust in the Martian atmosphere plays a significant role in its climate. It reflects sunlight, preventing the surface from heating up. This contributes to the overall cold temperatures on the planet. But there's evidence to suggest that Mars once had a thicker atmosphere and a warmer, wetter climate. Riverbeds, lakebeds, and minerals that form in water have been spotted on the Martian surface. These features suggest that Mars could have supported liquid water, and thus, possibly life. However, around 3.5 billion years ago, Mars lost its magnetic field, causing its atmosphere to be stripped away by solar winds. This led to the cold, dry desert we know today. Understanding Mars's climate and atmosphere is key to understanding its potential to harbor life. Our journey to Mars is far from over. What does the future hold? As we gaze upon the red horizon, we can't help but imagine the upcoming missions that will further unravel the mysteries of the Red Planet. One of the most thrilling ventures on the horizon is the Mars Sample Return mission. This ambitious project aims to bring back Martian soil and rocks to Earth for the first time, giving scientists a chance to study Mars geology and potentially its past life in our own laboratories. But that's not all. We are also looking forward to the day when the first human footprints will be imprinted on the Martian dust. The potential for a permanent human presence on Mars is no longer a far-fetched dream. Plans are underway, with ambitious timelines set by organizations like NASA and SpaceX, to send human missions to Mars within the next 2 decades. These future explorers will not just visit Mars, but they will live there, setting up habitats, conducting research, and maybe one day, transforming Mars into a second home for humanity. The future of Mars exploration is a testament to our insatiable curiosity and our relentless pursuit of knowledge. As we continue to explore Mars, we're not just learning about another planet, we're learning about our own place in the universe. So let's keep looking up, because the best is yet to come.